Okay, so just a couple of things when you're proving stuff. Some of these are particular to geometry. Um, the first thing is the idea. So the main part of the proof is what's the idea. There's no point in trying to learn off this line and that line and the other line. What you need to do is learn what is the idea or the trick in each proof, and usually the idea is contained in the construction. So if you want to prove that the three angles in a triangle are all equal, the construction you do is you draw a line up here through one of the points parallel to the other side, and then you show that these two are equal because they're alternate, and these two are equal because they're alternate as well, and these three here add up to 180, so that means the three in the triangle add to 180. But the trick, the idea, is the construction, and generally, not always, but generally the idea is the construction, and that's really the thing that you need to remember. Don't try and remember all of these things. The second thing that you need to remember is the layout, and the layout of all the proofs are the same. First of all, you have the theorem, and that's the thing that they will ask you to prove. They don't give numbers like theorem 14 or theorem 7 or whatever. They will say, you know, prove that if two triangles are similar, their sides are proportional in order. So you write down theorem, if two triangles are similar, their sides are proportional in order. That's the theorem. The next thing is you do a diagram. And a lot of times that's just you trying to remember what the hell you're being asked to prove, and the diagram is really going to be the key to it, because that's where the construction will come in. So the next thing you write down is you write down what you're given. So you're given two triangles that are similar, or you're given up here just a triangle. Next thing you do is you write down what you want to prove. So that's usually very straightforward. I want to prove that angle 1 plus angle 2 plus angle 3 equals 180 degrees. The next bit is the key bit, that's the construction. And that is usually the most important bit. So you go back to the diagram and you draw something. For almost all of the proofs, you end up drawing something. And the last bit then is the proof. And usually if you have it right up to here, you're going to get the proof right. Okay, just a couple of notation things about lines. So AB is a line. It goes on forever in both directions. If this is A and this is B, then that there is AB. So if I'm interested in something being parallel to AB, I can write this, that's no problem. If I write this is a line segment, and it is just the bit between A and B. So if I'm interested in the side of a triangle, this is what I'm interested in. I'm not interested in this, I'm interested in this. That can be the side of a triangle. That isn't the side of any triangle because it keeps on going forever. Alright, and the last thing is that this with the straight lines is the distance or the length. So it's the distance between A and B or the length of the line segment A to B. Okay, so it's important that you kind of keep them straight in your head, what the three of them mean. There's a similar thing with angles. If we have an angle, we generally put in that sign to show that we have an angle. So this is the angle ABC. So you would pretty much never have two angles equal. What this means is that they are literally the same angle. What you would often have is the size of two angles being equal. So this angle is the same size as that angle. And again, you put the two straight lines on it to say that you're talking about the size of it or the magnitude of it. That's the same up here. You're talking about the magnitude of the segment AB. The magnitude is the size. So again, this is what you do. Now, in some of the proofs, especially where you have a lot of angles to deal with, it can be useful to label the angles 1, 2, 3, and then you would say maybe the angle 1 equals the angle 4, that kind of thing. Just remember to put in the angle symbol beforehand so you don't think you're saying that 1 is equal to 4. Congruent triangles or similar triangles, the main thing with them is to remember to write them in the correct order. So suppose we have a case like this. Let's say that angle is equal to that angle. Let's say that angle is equal to that angle. And we'll say this side is the same as this side. So if this is A, B, C, and this is D, E, F, we don't say that the triangle ABC is equal to the triangle DEF. The reason we don't is that the A here doesn't correspond to the D here. The A here is next to that double circle angle. Well, it corresponds to the point F over here. So ABC will correspond to F. Then you look at the next one, B here. B is at the dot, that corresponds to E. and then C is the last one, so that's D, which is the last one. So you just make sure that you have whatever order you have the points in here, the points here have to correspond in order. And the same is true if you're saying two triangles are similar. When you write down the two triangles are congruent, you're not just saying they're the same size, you're also saying which vertices or which corners correspond to which other corners. And the very last thing to say here is that you need to justify everything. So if you're saying two angles are equal, you need to say it's because they're alternate or corresponding or whatever. Two handy ones are given. So if it's part of the question, then it's been given. Alright? And the other one is by construction. That's another handy one. By construction, in other words, because of the way that I did my construction, then decide AB equals decide XY, or whatever it is. Alright, so just keep those in mind. The main thing is the idea of the proof is really what you want to be trying to remember, and the layout of the proof is always the same and is extremely important.